That old hardwired relay panel can become a PLC program. The contactors, the push buttons, the rat's nest of wiring, all of it. And there is an exact, repeatable way to do the conversion. No guessing. In this video, I will take a real hardwired control circuit and convert it to ladder logic, step by step. We start with the circuit. Then we build the one table that makes the whole thing painless. Then we translate it, contact by contact, into clean ladder. And at the end, the part most people get wrong. What you must never move into the PLC. Let us start with the panel. Quick note before we dig in. This is from PLC Simulator, where you can build this exact conversion free right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the wiring diagram. Here is the circuit we are converting. A classic motor start and stop. It is hardwired control, relays and contacts, no PLC yet. Trace it, a normally open start button. In series, a normally closed stop button. Then the contactor coil that runs the motor. And here is the clever bit. A second contact, wired in parallel around the start button. That is the seal-in. When you press start, the coil energizes and that parallel contact closes. Now the coil holds itself on, even after you let go of the button. There is also an overload contact in the line, a normally closed safety interlock that drops everything if the motor overheats. I broke this exact circuit down in the motor start-stop video, link below. This diagram is our source of truth. Everything in the PLC has to match it. Now the step almost everyone skips, the I/O assignment table. Do not touch the ladder yet. First, list every physical wire that goes into the conversion. Every input first. The start push button is a physical input. Give it an input address. The stop push button, another input. The overload contact, another input. Then the outputs. The contactor coil is a physical output. Give it an output address. That is the whole table. Field device on the left, PLC address on the right. Why bother? Because once the table exists, the ladder almost writes itself. Every contact and every coil in the diagram now has an address to point at. No more wondering what wire maps to what. The table is the bridge between the panel and the program. Now we translate, and there are only 3 rules. First, a hardwired, normally open contact becomes an XIC. Examine if closed. It passes power when its bit is on. Second, a hardwired, normally closed contact becomes an XIO. Examine if open. It passes power when its bit is off. Third, the relay coil becomes an OT, an output instruction at the end of the rung. So our circuit maps straight across. Start is a normally open button, so it becomes an XIC on the start input. Stop is normally closed, so it becomes an XIO on the stop input. The overload is normally closed too, so another XIO. And the motor coil becomes an OE on the output. The seal-in? That parallel contact around start becomes a parallel XIC of the output itself, the software holding contact. Same circuit, same behavior. Now it is a ladder rung. Now the part that matters most. Not everything moves into the PLC. The emergency stop and the hardwired safety chain stay hardwired. A safety function must drop power directly. It can never depend on a scan of PLC logic to keep you safe. So the e-stop drops the contactor and hardware, the same as it always did. The PLC can read its state, but it does not stand between the button and the power. That rule is not optional. Once it is built, verify it. Trace the diagram against the rungs, one device at a time. Start button, is it the right XIC on the right address? Stop, overload, the seal-in. Every element on the diagram should have a home in the ladder. If you can read a wiring diagram, this is the same skill. I cover reading the diagram and ladder basics in the linked videos. So here is the conversion, start to finish. Begin with the hardwired circuit. That is the source of truth. Build the I/O table. Map every field device to an address. Translate the contacts. Normally open to XIC, normally closed to XIO, coils to OT, the seal-in to a parallel branch. And keep safety hardwired. The e-stop never lives in the PLC alone. Do those 4 steps, and any relay panel becomes a clean program. Now go build it. If you want to convert this exact circuit hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.